show that area of triangle AED plus area of triangle BEC equals area of triangle AEB plus area of triangle DEC. So if we call area of AED to be A1, while we call this A2, this is A3, and finally this is A4. Want to prove that the sum, if you sum these two opposite areas, it will be the same thing as the sum of this. So we know that these are triangles, and the area of a triangle is always half base times height. So we need to locate the height. So assuming from here to here is the height for triangle AEB. So if you call here H1, why this is the height for triangle DEC. So if you call it H2. So we know that area of a triangle is half base times. So we have that A4 now. A4 is half base. Okay, you remember this is a parallelogram, and in a parallelogram opposite sides are congruent. So if we call from here AB to be A, DC will also be A because opposite sides are congruent. So we have the base is A while the height is H1. And for area 3, A3 is also half A times H2, half base times height. So let's sum the two areas. So we see that A4 plus A3 is half AH1 plus half AH2. And looking at these two, they have common term. The common term is half A, while this is H1 plus H2. But remember, this is a parallelogram. We know that area of a parallelogram ABCD is always base times height. Our base is A, while the height is the sum of the heights of H. That's triangle EAB, and that, so which is H1 plus H2. That's the height of the parallelogram. So meaning that we'll replace A times H1 plus H2 as area of parallelogram. That's ABCD. So common sense will now tell us, since the sum of these two gives half of the parallelogram, implies that area of the sum of the area of the remaining, which is A1 plus A2, will still give us the same thing. Yes, because half plus half is 1. So we've proved that. Therefore, A1 plus A2 must be A3 plus A4. As find area of triangle BEC given other areas. As you can see from the diagram, we have two pairs of parallel sides. This, and this. This is parallel to this, while this is parallel to this. So making ABCD to be a parallelogram. And there's one property of a parallelogram that states that in any parallelogram, that the area at any point inside the parallelogram, maybe if you have A, B, C, D, we have A, B, C, D. The area of A, maybe O, AOD is A. So these are the areas. It states that the sum of the opposite area, A plus C, must be equal to B plus D. That's the theorem. So what you have to do is to apply it here. From that, we'll get the answer. So if you call area of BEC to be call it A. So here A. We now see that 5 plus A must be equal to 15 plus 11.5. So we now see that 5 plus A must be equal to 15 plus 11.5. So A is 15 plus 11.5 minus 5, which is 26.5 minus 5 is 21.5. So our answer is option B.